Hello everyone, this is our next video of Fortinet NSE 4 series, and today video we are going to understand about the routing concepts on the Fortinet. We'll also understand the default route and other routing concepts. So as we already discussed the static routing and the dynamic routing in the previous videos, if you have not watched that videos, I suggest you watch that videos. Then you will able to understand the static routing and the dynamic routing. We perform also a lab. So let's start with the today video with the default route. So why we need a default route and what is the default route? The default route has a destination of 00 representing the least specific route in the routing table. It's a catch-all routes in the routing table when traffic cannot match a more specific route. Also, it is more instance you will configure a next hop interface and the gateway address pointing to your next hop. If your FortiGate is sitting at the edge of the network, your next hop will be your ISP gateway. So let's understand the routing, default routing in the whiteboard. So we previously understand that routing has three types, that static routing and dynamic routing, which works on the protocols. These two routings we discussed. So another is the default route. Let's say we have this FortiGate firewall and now this is our ISP network, and here we have some LAN users. So they have initiated some connections, let's say google.com. Then this traffic once reached to the FortiGate, obviously we need a routing to route this packet. So what FortiGate will do? FortiGate will first check the static route. Why static route? Even before the static route, they will check the connected interface because the connected interface is having the highest AD value. And after that, they will look up for the static route. So this destination is having any static route? No. Then the FortiGate will look up for the dynamic routings. So is there we have that routing protocols like BGP, OSPF. We have that. We can learn those routes from any of the protocols. Then FortiGate will see. No, we don't have any dynamic protocol. Now at the last C, FortiGate will forward that packet to this ISP because we have added 0000/0 and we point that we have definitely will have one next hop, that is, let's say 4 times 2, and this address is the next hop which is we provided by the internet provider so that we can send all traffics towards the ISP. So if we don't have any matching route for the any specific destination, those traffic will forward it to the gateway. That gateway will known as a default route, means every all over traffic which don't have that routing information will send it over to the ISP. And also second thing, the Google is having their own destination addresses, and those destination addresses we are not aware about it. So that's the reason we use the default route on the edge FortiGate firewalls. So let's move on to our slides now. So we understand the default route. Let's understand the administrative distance. So after which routes are selected first by different protocols for route management. For load balancing, the default is 0. So I just explained that directly connected having the least value means that they will be highly preferred. After that, we have the static route 0. This is for the Cisco, and for Fortinet it is 10, and internal EIGRP is 90, OSPF 110. So every protocol is having their AD value. So based on this AD value, they will select the routes. We can discuss this way. Let's say if I have a one route which is coming from the OSPF and also another route which is coming from the RIP. So which route will be which? So for let's say these are connected to this Fortinet, and they backendly they are connected with any servers like that. So how that FortiGate will decide whether I should forward with the OSPF or RIP. So to maintain those confusions, that routing protocols are working with the AD value. So the AD value of the OSPF is 110. So the least will be preferred, so that that FortiGate will forward the packet to the OSPF, will not take the preference of the RIP protocol. So this is the information related to the OSPF administrative distance, that AD value. Now let's understand the black hole routes. So black hole routes is a definitely, it not means that, let's say if you want to drop any kind of destinations, you can create the black hole rule. So this is used for the dropping the packets. Define a black hole route so that traffic is dropped. So in this image we can see this will be the destination and then interface is the black hole. So once anyone try to reach this destination, the traffic will hand over to the black hole and those packet will be dropped. And I already explained the administrative distance. It is mentioned here, it is as a 10 in the case of FortiGate. So another topic will be the reverse path lookup. So whenever a packets arrived at the interface on the FortiGate, the FortiGate determines whether the packet was received on a legitimate interface by doing a reverse lookup of using source IP address. In the packet header, this protects against the spoofing attack. So once the packet, let me go back to the my whiteboard. So basically what is the RPF means that, let's say this is our FortiGate and here are some LAN users. Once they initiate any traffic from using their source IP, let's say 192.168.10.10, kind of that. Then let me clear it, write it down, or we'll take any IP, let's say 1111. So what FortiGate will do, they will take the reverse lookup so that this source, is it my interface or not, so that any other IPs could not send any spoofing attack. So to prevent that spoofing attack, this FortiGate is using the RPF, reverse path forwarding. Let's reverse path lookup. So that is the basically functionality of reverse path lookup to prevent the spoofing attack. So that is the reason reverse path lookup is happening. Using the source IP in the packet header, this protects against the spoofing attack. If FortiGate does not have the route for the source IP address through the interface when the packet was received, the FortiGate drops packet as RPF, reverse path forwarding. So if FortiGate don't know that this, if FortiGate is having don't know route about this 4x1, then that packet will drop at RPF level. So, and RPF is having two modes. That first one is the feasible path, second is the strict, and these is the two commands. The if configure the strict reverse path forwarding, so this will be the command, and remove reverse path forwarding chain, then this will be the command, we can remove it. So in the case of one routing information, like only one hoop will use for the destination, then feasible path will use. In the case of two destination, let's say this is the FortiGate and this will be the destination. If it's reachable by two routes, then to take that decision, strict will use. If we have only one route, let's say if you have only one route, So on that case, that feasible path will take the precedence on that cases. And this is the command to enable it. Strict CRC check enable and remove to the interface name and source check disable it to disable that. And after that, asymmetric routing. So asymmetric routing occurs when the request and response packet flow on a different path that do not cross the same firewall. So in this diagram we can see that PC1 is sending response from the FortiGate, but now PC2 is sending response from router towards this FortiGate. So the ongoing path is using the FortiGate, but the return path is non-FortiGate. So if the packet is going from one path and coming from another path, that situation will known as the asymmetric routing. So to permit the asymmetric routing on the FortiGate firewall, this is the command. So using that you can permit it. Otherwise, this asymmetric routing, it is dropped by the FortiGate firewall. And also, as per industry standard, asymmetric routing is not recommended at anymore. So in that any situation, if you need to allow the asymmetric routing, then you can use this command to allow the asymmetric routing. Config system setting set AOS enable. So this is the discussions related to the asymmetric routing. And asymmetric routing on the UDP packets. So what will be the impact of the UDP packets on the asymmetric routing? So the asymmetric routing does not affect the UDP packets. UDP packets are checked by the session table regardless of asymmetric routing. So in the case of TCP packets, those packets will be dropped at the FortiGate level because of asymmetric routing. However, the UDP packets will not dropped by the FortiGate firewall, but we need a policy to allow the asymmetric routing. Routing changes. When a routing changes occur, routing lookup may occur on the existing sessions based on the depending certain configurations. So if firewall is processing any traffic and that session has been formed, and on that time that routing changes has been occurred, so it may that firewall or FortiGate will perform the session again, the route lookup on the certain configurations. So maybe that existing sessions will drop, firewall will again look up for the updated routing, and based on that they will create a new sessions allow. And routing changes without source net. So when a routing changes occurs, FortiGate flush all routing information from session table and performs a new routing lookup for all new packets on arrived by default. So if the connection is running, those connections are not using the source net. So on that case, if route changes occur, FortiGate flush all routing information from the session table and perform the new lookup. All packets arrived by default. So this is the command to that enable it. Set preserve session route enable. And basically if we want to, let's say this is basically this will like a flush and then perform a new session. To prevent this situation, this is needed like a preserve session route table. So only the new connection which will come after the routing information update, then those sessions will take the updated routing tables. Other than that, sessions which are already exist on the FortiGate firewall, those will take the older routings. So if you want to change the behavior, because this is the by default behavior, if you want to change it, then using this command you can preserve the sessions on the routing level, older routing. And let's other is the routing changes, which SNAT means the source net. When source net is enabled, the default behavior is opposite that when source net is not enabled. After a routing change occurs, source net keep using the same outbound interface as long the old route is active. This may the case of priority static route change. So in the without source net, the behavior was when the routing change occur, they will take the new lookup. But in the with the source net, they will not check anything, and until that source net is not enabled. After a routing change occur, SNet keep using that same outgoing interface as long as old route is still active. So this in the case of we change the priority and static route, that or that. So to reverse that action, this will be the command. So this was the video related to some behavior of the routing protocol routings on the FortiGate firewall. I hope you enjoy this video. Thanks for watching Firewall Experts.